This video will demonstrate using the reflections in parallel lines theorem. First, let's talk about what that really means. Here we have lines K and M, and we're saying that they're parallel. And then we're going to do a reflection in line K. And that's what takes line BA and makes it B prime, A prime. Okay, so we're going to make this a little bit darker. It makes it that. So we reflected it across line K. Then we're going to reflect B prime, A prime across line M. We're going to get B double prime, A double prime, because we have this new segment. So what's important to note is that segment A double prime. So that's from A all the way over to A double prime. It's saying that that is what's perpendicular to line K and line M. Right, then we're also able to say that that distance from A to A double prime is twice the distance between K and M. What that means here is that let's say that I have a value between K and M is 3. Well, that means the distance from A to A double prime is going to be twice that. And 3 times 2 is 6. So let's apply that knowledge. So here, in this diagram, we have a reflection in line K that maps GH, which is the blue segment, to G prime H prime, which is the red segment. And then a reflection in line M, which reflects G prime H prime, which is the red segment, to G double prime H double prime, which is the green segment. Okay, and then we're also told that the distance from H to B, okay, so from here to here is 9. And we're told that the distance from B to H double prime, so from here to here, is 4. Okay? Now we're going to name any segments congruent to each of the segments, whether it's segment GH, segment HB, and segment GA. So here we can see that segment GH is congruent to segment G prime, H prime. And we can see that GH is also congruent to G double prime, H double prime, that segment. We are also able to say that segment HB is congruent to segment H prime B. And lastly, we're able to say segment GA is congruent to segment G prime A. So let's mark those. GA, and then segment G prime A is right there. Then HB and segment H prime B. Well, now we want to know, does AC equal BD? And the answer is yes, it does. And here's the reason. Because G to G double prime, okay, that segment, and H double prime are both perpendicular to lines K and M. So what that means, right, is that we have segment BD and segment AC are opposite sides of a rectangle. If they're opposite sides of a rectangle, then they have to be the same distance. So you can mark that here. The rectangle we're looking at is this rectangle right here. So there's our perpendicular lines. And then this is the side of the rectangle that we're talking about, right there and right there. Okay? And lastly, we're asked, what is the length of G prime? Okay, so because of the properties of reflection and what we have written already with our congruence, is we're able to then say that this has a value of 9 and this has a value of 4. Okay? So basically, the reflections in the parallel lines theorem implies that G double prime, should be equal to H double prime, which is 2 times the distance of whatever B is. So the length of G to G prime is going to be 2 times 9 plus 4. So if we go from there, G prime is going to equal 26 units. And so from G to G double prime, we have 26 units. And that's what we're looking for, is what is the length from the segment G to G double prime.